We are Team Amrita Racing, a Formula student team. Myself, Harish TS, the team captain from Department of Electronics and Communication Engineering. This is Sri Hariharan from the Department of Mechanical Engineering. That is Hari Lokita from the Department of Mechanical Engineering. This is Mauli Rajguru from the Department of Electrical and Electronics Engineering. This is Harshni M from the Department of Electronics and Communication Engineering. This is Abdul Rahim from the Department of Mechanical Engineering. And this is our first year electric race car which we have done. We have made this car for the competition SAE India Supra 2024, and we have won overall statics, and we have ranked all India ranked second. This vehicle is powered by Agni 119R motor, which has a peak power of 16 kilowatt and nominal power of 8.6 kilowatt, and we have used Moly cell 21700 cells, which are connected through wire bonding.
My name is Chirag Pradeep and this is Rishabh Kumar. We are from 4th year BTech in Aerospace, and we made this drone for a competition in SAE ADDC 2024. The mission profile for us was to design a drone that would autonomously take off, reach the destination, land, drop the payload and return to launch. So this drone is capable of doing and completing the mission, and the payload we designed for last mile delivery for medicines. So it's capable of carrying 100 grams and has a flight time of 15 minutes. The total takeoff weight of this drone is 1.8 kilograms, and it's a X configuration drone with a GPS, flight computer and a payload box, capable of dropping the payload on its own by 2 rotating drones that are controlled by a servo motor. So the autonomous mission is planned on a software called ArduPilot Mission Planner, in which we can feed the waypoints and the altitude and everything and feed it to the flight controller, which will tell the drone how to navigate through the waypoints.
So we have designed all the chassis. So these are carbon fiber tubes which were bought, and this is the carbon fiber sheet, and we have designed the carbon fiber sheet in a CAD diagram. Then we have water jet cut it. Then these are the 3D printing parts. We have used 3D printing part because they dampen the vibrations. So we have made 4 3D printing part for the motor mount and 1 3D printing part for the camera mount. So this is the camera. So this is the video telemetry. What camera sees sends information to the video telemetry. We have antenna here. This transmits the data for the video. This is the video receiver. So this receives the data from video transmitter, and this is shown in the OSD. This is an on-screen display. So we can see what all is seen by a drone. So if we can see the movement of the drone. If there's any obstacle, if there are any obstacles, we can see the live video, live data, and then we can change the flight path.
We are from Amrita Vishwa Vidyapeetham from Aerospace Department, and this is our drone called the Albatross. So this is a completely autonomous drone which can fly for 12 minutes, do missions such as from takeoff, loitering, identifying the targets autonomously, going to the targets, dropping the payload, and coming back to the home. Everything autonomous. So as you can see, there is a payload bay here which can open and close using a servo mechanism. So you can see this. So now we have a camera here, which is a TVL camera, which is the analog camera, which will transmit signals live to the pilot so that we can control the drone with this camera. And there's a mount for the passive camera, which is the ArduCam. That will send data through this Raspberry Pi, which will do image processing of the camera and send the positions of the drone. Let us say our target is 10 meters ahead, so this will give 10 meters go friend command to the PICSOC. That will help the drone to navigate to the desired destination and drop the payload efficiently. And the entire drone costed 1.2 lakhs.
We are from Department of Aerospace, and you see the drone over here. Its name is Chakshu. It has different purposes. The main purposes of this drone is to convert a fixed wing, which is our another design, into a VTOL. VTOL in the sense vertical takeoff and landing. So for any fixed wing aircraft, we need a runway to take off and land. But when with the help of this drone, by integrating this drone into that fixed wing, that fixed wing can be converted into a VTOL. So then we don't need of any runway to take off and landing. The other purpose is the camera over here. With the help of this camera, we can do human detection and human tracking. This can also serve as campus monitoring. And also the third purpose is payload dropping and payload delivery. As you can see over here, uh, during inauguration of Anokha, we did a banner drop with the help of this drone. The overall MTOW of this drone is 3 kgs with a payload capacity of 600 grams. And this drone, with the help of this 6700 mAh LiPo battery, we can achieve a total of 22 minutes of flight time.
So I am Rishi Krishna from Aerospace Department, Amrita School of Engineering. So today we are going to see about a test bed drone which is built for pilot training and sensor testing. So the main application of this drone is to test the various sensors and the calibrated values at certain altitudes. First, we are going to discuss about how to make a flight. If you are going to make a flight controller at your own, the sensors which has been used by you will be changing to the actual sensor. So for testing that, we will be installing the flight controller here. We will be installing a flight controller here, and we will be trying to get the values that which are matching, and we will be optimizing it later. So once there are two receivers installed. One is for the FPV camera, which helps us in guidance of the pilot, and next we will be having the telemetry, which will be used to get the data from the ground station. And there are 4 BLDC motors installed, which is each is 1400 kV rating, and we have 4 propellers at 30 amperes rating, and the flight controllers installed is APM 2.10, and it also supports GPS modules, which helps us in autonomous flights.
Okay, so my name is Krishna and I'm aerospace fourth year, and these are like the beginner's drone. So if you want to learn about these drones, like how to fly them, you can use these drones because they are easy to handle, and you can use your mobile in order to like control these drones. Like we have an app, it's called Pluto Controls. By using that, we can control all these two drones, and this is like Wi-Fi enabled, so we can like connect it using a Wi-Fi. So it's connected to my phone now. We just have to open the app. As you can see, I can connect it. I connect it to my phone, and I can control it using my phone. Of around like 8 to 10 minutes because it has like an 800 mAh battery, and the max range of this is like 8 meters, and that's it. And it uses a flight controller called like Primus V.
Hello, my name is Sai Teja. I'm from Aerospace 4th year. Now we are going to see a demo on this fixed wing RC plane. This plane is named as Guinea pig. It can carry a payload of around 200 grams. It carries the payload and drops at the desired location. Its total weight is around 1.2 kgs. It can fly in the air up to 10 minutes, and its range is about 1.5 to 3 kilometers. So these are ailerons. Those are that is rudder and that is elevator. These are used to control the aircraft in the mid-air, and these are the rotors. These produce the maximum thrust from this. So it will conventionally take off, reach the location, drop the payload, return, complete its mission and return back.
I'm Abhinav from the Aerospace Department. So this particular RC aircraft has been modeled and built to be a specific test bed for VTOL capability. So VTOL stands for vertical takeoff and landing. The advantage of a drone is that it can take off at a given location, and the advantage of a fixed wing aircraft is that it is much more efficient. It can travel for a longer time and for a longer distance. So what we want to do is combine both these positive aspects into one aircraft. So we have two mounts here. These two mounts will have the arms of two drones, the two arms of a drone. So it will end up looking something like this. So during takeoff, we will use the 4 rotors of the drone to take off, gain altitude. Then we will use this motor and this propeller to gain horizontal velocity. Once we gain sufficient horizontal velocity to support the weight of the entire aircraft, we can turn off the 4 motors, or we can operate them at a lower RPM. So that is the main purpose of this drone. Currently it is working as a fixed wing aircraft itself. So we can use that itself to collect data regarding the atmosphere at altitude. We have an endurance of more than 30 minutes. So we can use that to collect a lot of data. So this same aircraft has been modeled in a simulation software called Explain, which is being controlled using this transmitter. So all the inputs are being given here. Throttle, pitch, roll, and yaw commands are given here, which is being translated here. So the simulator software is used to collect data. So we want to test a lot of different aspects of the design before we actually manufacture it. So we collect data from the simulator to see if our design is feasible, make the necessary changes that we can, then build it physically to test a practical model.
We are from AI department, second year. So our project here has two arm manipulators, a conveyor belt and a camera sensor, and two more sensors. So starting off, this camera sensor has a deep learning model inside it, which is YOLO, you only look once. What it does is it takes the camera feed and it has been trained on the images of the block. So after taking the feed, it breaks it frame by frame and looks at it and finds the blocks in it. After identifying the blocks in the image, it puts a bounding box around it. After putting the bounding box, it finds the center of the block. On finding the center of the block, it conveys it to the robot. Now here it is a pixel coordinate system and there it is a robotic coordinate system. So being a different system, we use linear regression for converting from this to that system. On doing that, after finding the center, it takes these blocks, place it on the conveyor belt. And after placing it on the conveyor belt, here on the other hand, we have another system. Here we have an IR sensor. So what the IR sensor does is detects motion. So after detecting the motion, it will take the blocks and initialize a set of commands. Starting off, this robot will move to its initial position. Then we have a color sensor right here, which will find what the color of the block is. How it does that is shines a bright light on it. The reflecting most dominant tribe color will it will find what the color is. Based on that, it will pick it up and place it over there. Starting based on that, it has a fixed coordinate system. So for example, this is blue, red, green, and there will be yellow over here. So how it does that is, this is a non-identified color, basically none of the above. So it will place yellow separately. In this, we have this deep learning model. This is how the camera feed looks. So in this is the green bounding box, and the red dot is the assumed center, which it will be converted to the robot coordinates, and the robot will go and pick it up and place it on the conveyor. So there's a small delay because there are two different systems. This system is coded, the camera and the robot is coded in Python because YOLO is very easy to implement in Python. So it's a integrated code. The other coordinates are all fixed. On the other hand, we have a robot laboratory, which is an inbuilt application for this robot. So it's similar to Scratch code style. All of them have a separate block, so you can implement them. It's a very easy to write code. This is how the color sorting works.
So, Namaste, myself from AI department. I'm Amrita of second year AIDB batch. So the robot that I'm presenting here today is a spider robot. One of the features which is developed is the gesture mimicking part. So initially we have coded in Python using media post model. In that, what basically happens is that the robot first identifies a human which is coming in its frame, and that once the body is detected, then it goes for identification of three parts of the hand, which is basically the shoulder, elbow, and palm. So using the coordinates of our like shoulder, elbow, and palms, it tries understanding what is going on. It is actually basically making a 2D frame, sir. So what basically happens is that once the human like whatever our pose is detected, the code takes it and gives the angle in which it sees the difference. So for initialization, we do a pentagon pose, which basically says that we are asking it to mimic us. So in the code, we have written that once the pentagon pose is detected, we can start with the motion. And once the pentagon pose is done, we go for the T pose, where it helps the machine or the language like the code that we have written understand the difference between each point. So once the point is known, we can like understand how much angle difference is coming.
lecture. I'm Shakti. This is Pathvi. We are from the AI department. This is a robot dog. The robot's name is Ross Pug. It's from a company called Hi Wonder. It's a Chinese company. They specialize in robotics. This robot's hardware consists of an NVIDIA Jetson Nano board with an expansion board on top. The sensors it has are the IMU sensor, a LiDAR, and a camera. Each leg has 3 servo motors, giving us 3 degrees of freedom for each leg, so a total of 12 degrees of freedom. Software wise, it's using ROS. So, a student who wants to learn robotics, instead of doing small projects with Raspberry Pis or Arduinos, they could do a project on a robot like this, which uses a much more advanced board and uses ROS. ROS is used in the industry everywhere. Any factories where they use automated production lines, they'll be using ROS. So, a beginner who learns to program using ROS, using a robot like this, and doing a project like what we have done today, they could use that knowledge in the industry directly.
In our project, what we have done is we are just using the camera over here, and then we are telling the robot to kick a ball. So what the robot will do is it will walk around, find the green ball, and then calculates its distance and walk around accordingly and kick it accurately. So all that we have used over here is Python and OpenCV. So using those libraries, how the internal structure is working is basically we calculate lab values and using luminance and all that, and we detect the ball. So we get a boundary out of it, and then we have defined some walking motion for the robot. Those are called as gates. So
when people want to program a quadruped robot such as this one, they'll usually refer to the YouTube videos such as Boston Dynamics' dog videos. So in those videos, they have a much bigger quadruped robot where they can kick and push the robot, and the robot will be able to balance itself. This robot is capable of doing all that. But since our goals are more aligned with the educational purposes where a beginner could learn robotics, what we have done is we have pre-programmed each of the walking cycles. These walking cycles are known as gates, G-A-I-T-S, gates, and we have programmed 3 of them. So gates are essentially the pattern at which the leg moves such that the robot can walk properly. So what happens is we have programmed 3 gates. One of them is trot, the other is walk, and the middle one is amble. Trot is the fastest walking cycle, and walk is the slowest. But walk is more stable, and amble comes between trot and walk. So we have used trot for our program so that it reaches the ball faster. So the way the OpenCV functions work is that all the programming that this does is only using Python, OpenCV, and ROS. So when it sees a green ball such as this one, it'll look for the green blob in the frame, and it'll look for the biggest green blob in the frame. It'll assume that the biggest green color object in the frame is the ball. So it'll find the center point of this green ball. Then it'll decide whether to move forward, left or right based on its own program.
I'm Srinitha from AID department. So this is an autonomous navigator which will move to a destination point without any human intervention. If there are any obstacles in between its path, it creates a new optimal path and moves it. So as you can see, if you give it a destination point, it moves there. So it has a sensor in it which detects the obstacles, and based on that it moves in its path. So once it comes, you can give some other locations also. This is the 2D map which it has detected and gave it. With the sensor in it, it creates a 2D map like this. And if you give a location here, somewhere around, like that, then it will create its own optimal path. The line you can see is the path it goes.
I'm Yashwati and this is Rubantika. We are from robotics department, and our project is terrain responsive wheel legged robot. So it has 2 functions. One is leg mode and wheel mode. So it detects the type of terrain it is in. So if it is a smooth terrain, it will be in the leg mode and transfers through the wheels. And if it is in the rough surface, or if it has to climb stairs and all, it will shift to wheel mode and walk one step at a time. And this has 16 servo motors, 4 servo motors per leg, and 1 DC motor per leg for wheel motion. And we used Arduino board for controlling the motors, one extender, and one buck converter for reducing the voltage for each motor. So the major application for this is home delivery like Amazon. So we'll just show the demonstration of how it transfers from wheel mode to leg mode. One of the advantages for this model is that the wheel itself acts as a leg. So here it will see the wheel motion, and here it will convert to leg motion and walks as a leg. And one of the flaw is that we tried to 3D print the connectors here, but due to budget constraints and time constraints, we bought the connectors online. So this is the leg home position, and this is the wheel position. So we'll show another demonstration for walking mode. In the future, we are trying to integrate with camera, and with the help of the camera, so here's how the leg starts working. It moves one leg at a time, and after every leg moves one step, the whole body shifts to the new center of mass. விட்டுட்டா? So this is the current progress of the project. We'll continue working with the project with integrating cameras.
So my name is Vismaya, and these are my teammates Tenmuri and Arpuda. So we are from EC department, CC branch. So we are third years, and our main aim of this project is to control an application using hand gestures and movements. So we've used two sensors, fiber sensor and flex sensor, and MPU 6050, and all these inputs would go to the Arduino Liatano. So from there, it's programmed in such a way that when you move and when you move your hand, that will be recorded, and that would act as a keyboard. And here we've interfaced in a gaming application, but in future we could integrate this into medical fields for as a robotic arms. So when we press, like when you tilt your hand, the card goes right and left according to the tilt. And when you compress your fingers, that option is used as a boost in this application. And when you lower your hand, that is calculated to be reverse and stopping the car.
My name is Guru Kumar, and I'm from EC department. So basically, our project is Pulmo Cloud, and it works on detection of temperature, humidity, and particulate nature of the environment. So suppose you have a elderly person in your home or someone with breathing difficulties. So why do you think a person has a breathing difficulty? So the first thing is pollution, right? So why do you think pollution is a major factor? Basically because of the particulate nature in the environment. Like there are more pollutant particles in the environment, and it goes inside trachea, and because of that the trachea contracts because the body senses it as a danger. So what we've done here is it basically senses temperature, humidity, and particulate nature of the environment and sends it to our app. So we've developed an app for it, and along with the app, it regularly updates the database. So suppose you have an elderly person in your home who's having breathing difficulties. So say the patient's over here. You can just say this whole hall is the patient's room. You can have this thing in the corner of the room, right? And what it does is constantly monitors the environment, and you know, if you have an elderly person who is, you know, ill, you have a caregiver, right? So suppose we set a threshold to this app, and suppose the particulate nature, temperature or humidity crosses the threshold, what it does is it notifies the caregiver, like the particulate nature or temperature has crossed the threshold, please visit the patient. And suppose the patient is feeling bored and wants to go out, what we does is the same module, it's a small thing, right? You can just put it in your pocket and forget about it. So you can have it with a buzzer and send it this along with the patient. So what it does is constantly monitors the environment in which the patient is going and constantly updates its database. And you know, when the patient is entering into a polluted environment, the buzzer beeps and the patient will be like, okay, then I should not enter here, I will go somewhere else. So it constantly monitors the environment and updates the patients so as to prevent the patient from suffering.
We are from CC second years, which comes under EC department. So this is the experiment which determines the ripeness stage of the fruit and how much dates it will be there for taking to next ripeness stage. So we are determining this with help of humidity sensor, temperature sensor and gas sensor. Basically, it is banana is an extreme emitter of ethylene gas. With major reason for ripeness is ethylene gas. With the help of ethylene gas and temperature and humidity, we are determining the stages of ripeness of the banana. We are transferring this value from data uh, from sensors to Blink software and importing Blink to HTTP local host website and determining the ripeness stage. We have developed an developed a data set for past 10 days and we have analyzed those. With the help of that data set, we are determining the stages of ripeness. This project comes under sustainable development, and we have many future scopes for this, and we have listed everything properly. And future scope, if you see with the future scopes, with the help of AML algorithms, we can determine the ripeness stage. We have next ideas for those things. And let's see. Now we will show the analysis for the data, temperature, humidity, and gas values. Gas values for these things. The graph determines the data set which we trained for past 10 days, and it's the output of the thing. Banana is partial ape, and it's 1 day is left for next stage of ripeness. You can see the banana. It is an overripe banana. Yes, you can see it. You can see a drastic difference in values in temperature, humidity, and gas sensors.
Here is the reading on this, but it is gradually increasing.
It would be gradually increasing. It shows the, after analyzing, it shows banana is overripe. 0 days left for consuming it. So we should consume it now itself, immediately.
My name is Akiran. I am from CC branch EC department. So this is our project, a robust locking system with a unique idea of using joystick as the input instead of keypads or a traditional fingerprint scan or face scan IDs. In keypads and all, the backend will, like, if you click the buttons, it will all happen in digital. But this will enter in analog. So there are two axes in this joystick, Y axis and X axis. By correctly setting the threshold for this, we can determine the direction, and if you enter the direction sequence correctly, you can open and close the lock. So now the correct direction sequence is entered and the lock is opened. This servo motor here is the imitation of the lock system, and if the same password is entered, the lock can be closed. We have set various fail-safe cases. Like if the lock is entered, the long password is entered 3 times, the lockdown will be initiated, and no one can enter the password unless the user authorizes it to. Then we also have another feature, like if the person who enters the wrong password, it will be captured in the hidden camera here, and it will be saved to a Google Drive in the UI we have created. And a live stream can be also be seen of the whole safe in the web UI. It can be accessed through this web UI. This is the UI that we have created.
Here you will stream the live stream whatever displaying before the log system, and
This was the front page of the URL where user can log in and log into the username and the password. Like, so we'll get this page.
The password here is stored in the memory inside the ESP32 in a hash format. So that's for security.
I'm from ECE. My topic name is IoT solutions for senior care and elderly people. So I'll just explain my project. The modules I've used are ESP32 CAM, ESP32 Pro or E. This is a pulse oximeter. This is GPS module, and this is accelerometer or MPU 6040 650 accelerometer. I'll just tell the functions of all these sensors. This module is called ESP32 CAM. This will show you the surrounding and environment of the person. And this is pulse oximeter. This will give you the readings of the heart rate and the SpO2 content. And this is GPS module, which will give you the exact location of the person. And we have used a function called geofencing, where you can where the caretaker can set a perimeter. When the person crosses the perimeter, it gives the alert to the caretaker. And this is the accelerometer MPU. This is mainly for fall detection of the person, and when the person falls, it will give the alert to the caretaker. And we have included object detection also in the camera model. So all these data are sent to a app which we have decided we have done it using Flutter.
I am Marul from second year CC department. Our project is about AR with IoT. So AR is a technology that's booming right now. We have come from an era where brick-sized mobiles were there, and now we have some sleek and slim mobiles which actually fit in our pockets. So what we thought was we could actually design some applications for products like Apple Vision Pro and Meta glasses and all. So what we did was we created an application with Unity. We used a package known as Vuforia. It helps us get features for AR camera and all those things. And we have used Blink as a cloud platform. This is a ESP32 board. It takes data from this temperature sensor and sends to Blink, and it can now actually be displayed in the our app actually. So now we'll give a demo of our app. So in the application, I made sure that only when the camera detects this target image, the UI pops up. So if I select some features in the UI, like on off in the UI, the bulb in the connected to the ESP32 board will turn on and off. Okay. We've also made another application. So this application gets data from this DHT11 sensor and then displays it on a dashboard in an augmented platform.
I am Abhinesh from CSE department, final year. So actually our project name is Intelligent Bin. In our day-to-day life, we are in a hurry world. So even though we keep separate bin, we won't separate our wastes. So we introduce a product of smart waste segregation. So in this bin, we keep the object, it will segregate to that particular waste. So we have four kind of waste: others, foods, metals, peppers. We have camera model here. In the camera model, object will detect and it will send to the pi. In that pi, we have the models. So if you classify which kind of object it is, it will go to particular angle, it will drop. So we have three servo motors to rotate a particular degree and it will drop. And then we have ultrasonic sensors in the every bin to know whether the bin got full or not. If it's got full, we have dashboard. So in dashboard, everything will be recorded of record. So we have gas sensors because from the food waste, smells will come. To avoid that, we are using gas sensor. If gas is found, we detect to the dashboard.
This is Shiva Prasad. I am from Tripoli. So I have made a project called Mini Waveform Generator, which is a miniature version of a typical waveform generator. As you you might have known a typical waveform generator generates a square wave, a triangle wave, and a sine wave up to a frequency of maximum 1 megahertz. This miniature version of the waveform generator can also do a square wave, a triangle wave, and a sine wave up to a frequency of 50 kilohertz. The basic principle of the mini waveform generator is that a 555 timer is configured into working as an astable vibrate oscillator which generates a square wave. When you integrate a square wave, that turns into a triangle wave. When you integrate the triangle wave once again, that turns into a sine wave. And then that's how three different waveforms are being generated. And also after every step of integration, you have an amplification stage, whereas in which you can change the amplification factor to the voltage needs whichever you need. That's the working part. So I'll demonstrate some of the waveforms being generated by the mini waveform generator. So first you will need to choose the type of wave you need. So currently it's chosen to be a square wave, and also you would choose the frequency range which you would need. Currently it's chosen under 100 to 1 kilohertz range. You can change the frequency of the wave by adjusting these potentiometers, and also you can change the amplitude of the waves by these potentiometers. You can reduce or increase, and also you can change the coupling mode, either AC or DC coupling mode. And also now I'll show some triangle wave. So this is generated by integrating the square wave, and also you can increase the amplitude of the triangle wave and also the frequency. I'll change it to a different range now. I'll show one. So this triangle wave is about 9 kilohertz of frequency. You can also now I'll show a sine wave of the same sort. Yes. So it's also 9 kilohertz, and also you can change the amplitude of the sine wave, either increase or decrease.
We are from School of Agricultural Sciences. The model and the project we are exhibiting is automated irrigation system using canopy temperature monitoring. So, as we all know that in recent years, India is facing many heat waves, water shortage problems. All this can be mitigated by efficient water utilization irrigation systems. We have come with a plan of automated irrigation system using canopy temperature monitoring. You might have a question, why canopy? So soil moisture sensor and temperature sensor are used in the existing automated irrigation systems, which is the indirect indices of crop water stress. So canopy temperature is a direct indices of crop water stress, which indicates the actual need of the water the plant needs. So this how this crop canopy works is, when there is a water stress in the plant, the photosynthesis or the transpiration is stopped in the plant, which leads to closure of the stomatal pore, which increases the crop canopy temperature. With this increase in the crop canopy temperature, the IR sensor camera records it and sends it to the microcontroller Arduino Uno, which sends the signal to the relay board, which automizes the irrigation. This helps in mitigating the ill effects of water stress in plant. For example, in tomato, when the crop is facing a water stress, it might have flower shedding problem, which can very diversely affect the yield of the crop. And also in cotton, due to the water stress, we'll be having boll shedding. This helps in mitigating those effects. When it is irrigated, the transpiration is then done. The stomatal opening is done and the exchange of gases is done. This transpirative and evaporative cooling brings the canopy temperature back to normal condition, and the irrigation is stopped automatically, making sure that the optimum water for the plant is reached. We'll be showing you a demonstration. Something about, we'll be irrigating the field down. It has stopped there.
My name is G. Veerashakti, and I'm from EC department, 4th year. So this project is electronic harmonium. and this is the main heart of the circuit, which is IC, and we have 15 combinations of circuit resistance in series, and this is another resistance which is said to be RA. This one produces pulse wave with different frequencies using the help of these 15 resistance and these 15 switches. All these resistance are in series, and all these switches are connected in parallel to the switch. All these switches are connected in parallel to the resistance. So when we click on each and every switch over here, these first when I click on this resistance, this switch, this resistance will be closed here itself, and then it will be taken into account so that there will be a certain amount of frequency. When I click on the second switch, these two will be in series, and it will give another frequency value. So when this is the working of this circuit. So to demonstrate this as a keyboard, we've designed this circuit in such a way that the resistance has been designed in a way that it gives us a proper Sarigama Padanisa. So I'll be playing the circuit right now. So this is one note, and here we have another high pitch notes.
Hello, I'm Madhava. I'm from EEE department. So I'm going to present you about the magnetic levitation, and also after the magnetic levitation, I'm going to present about the wireless power transmission and how the voltage is induced in the oscilloscope that we will be showing. For example, when we apply the voltage from the auto transformer, as you can see that as the more voltage we are giving it to it, the more height it will be raising. For example, now we are giving at a 70 volt. If we increase it to 80, it will give more, and it will increase it to 90, it will levitate more. Like that, it would be going 3 to 4 centimeters up. It will be going. It was going till 100 voltage supply. Now, if we come to if we bring this to the down, how it is now? Let's see how it is going. For example, by applying the Ampere circuital law, when we apply the thumb, when we imagine our thumb in the direction of the current, which has been in the direction of the current, the flux will be generated in the curl of the finger. Since the current is flowing like this, we are imagining our thumb to be placed here, and the flux is going inside the coil to this aluminum zinc. This is an aluminum zinc where it absorbs the heat of the copper, and also it will in contrast with the copper, this aluminum also produces some flux. Why the aluminum is producing some flux? If we are giving the voltage to the copper in the sense, this flux will induce some EMF, electromagnetic flux, in the aluminum heat sink, and this heat sink will oppose the copper flux, and then thus we see that it starts to levitate. This is the phenomena which is happening over here. So now let us understand if the flux has been created. If we take a conductor and if we place it on the uh, cutting the magnetic field, will some voltage would be generated. Let us see that. As we are cutting the electric flux of the main coil, you can see here that improper sinusoidal waves are coming, but it's still some of the sinusoid. So that EMF has been given over here. This is the noise, and these are the hormones.
My name is Jaganathan. I'm from physics department. So what we have did is a solar thermal evaporator, and which is actually a water purification method, which is actually conventional method of water purification. And what we have did is we stabilized this device, and we used a cost-effective method by using activated carbon, which is produced through burning coconut shells, and a form sponge, which is a polyurethane form. And what we do is we allow the contaminated or salinated water through the inlet, and over which we keep the foam, and this foam is coated with activated carbon and a mixture of polystyrene, which is actually the activated carbon absorbs the sunlight and converts it to heat using the photothermal process, and by which the water is evaporated, and which is collected through the drain, and the purified water is obtained at the outlet.
Hi, we are from Nest Lab, Physical Science, and then what we are basically doing projects on batteries. This is zinc ion batteries. This is a rechargeable battery which is low cost, and due to the material abundance it's low cost, and then it's reversible and safety and eco-friendly. These are the components that have been used for the batteries. This is a zinc foil which has been used as an anode. This is stainless steel which will be used as a current collector for the cathode material. This is our cathode material MnO2 which has been synthesized from our lab. Then this is a separator which will separate our anode and cathode. We'll place all this together and then we'll inject our electrolyte, and then we'll cover it with aluminum foil, and then we'll compress it to form a pouch battery with a voltage of 1.9. The same process will make a coin cell. The difference between pouch and coin cell is that this is more flexible than the coin cell, and for pouch we'll be using it for the mobile phones, toys and other stuffs. For coin cell we'll be using it for watches, clocks and things. These are the components inside the coin cell. This is a cathode. We'll place a spacer, and on top of this we'll place our electrode, and then a current collector. On top of that is our separator which will be dipped in ZnSO4 which is our electrolyte. Then current collector, our another anode electrode, then the spacer, then anode. Then we'll compress it with 70 kilogram per meter square pressure. Then we'll get a coin cell. When we stack these coin cells together in a series connection, we'll get a battery. This is a demonstration for the pouch cell batteries. This is solar cell with which we'll charge our batteries, and then this is how the charging process happens. And then connected, the light will glow. For this LED, this battery can glow at up to 1 hour with 15 minutes of charging.
I'm Adityan and this is Gayatri. We are from Amrita School of Physical Sciences. We work under Dr. N. Mulaganathan, and this is a representation of a redox flow battery. So what are batteries used for? Batteries are energy storaging devices. You can see that's a zinc manganese battery that we use to store small amount of energy. But in large grid scale application, like if you consider a remote village where we cannot transfer power from the city, we'll use a solar power plant. So the thing about renewable energy sources is that they are intermittent. So we have to store as much as energy as possible when we are getting the energy. So in a solar power plant, we actually use a large scale. We can actually use a large scale redox flow battery. So the advantages of a redox flow battery is that unlike regular battery, the redox flow battery stores electricity in electrolytes. So these are the representation of tanks. This is a miniature setup. Actually, we can build a large scale setup in villages with solar power plant. So the energy is stored in electrolytes and transferred through electrodes. Here we can see that the graphite and the carbon are used as electrodes because carbon and graphite have porous structure and they can conduct more electrons at a higher speed, and they does not react with any other materials that quickly. So because of that, if we connect a pump and flow the electrolytes through the electrodes, we can collect the electricity in a current collector. Actually, we can charge and discharge this multiple times. The main advantages of a redox flow battery is that we can scale the energy efficiency and power output independently. So if you want to just increase the energy efficiency of a regular battery, you have to deconstruct the whole battery. That is not economical friendly and highly cost involvement. So in a redox flow battery, you just have to increase the size of electrolyte tank. That is very cheap. So that's why you can easily increase the energy efficiency. So if you want more power output, you just have to increase the number of graphite stacks. So that's why the use of redox flow battery is highly promoted in foreign countries. Actually, NASA discovered this in 1980 as a new way of energy storage. In industrially, they use all vanadium redox flow battery, but in our lab, we are actually trying to come up with a new electrolyte which is much cheaper and can have a potential as much as of vanadium. So currently, we are working on ore ferrous redox flow battery where FeCl2 and FeCl3, and all these things are recyclable also, so they are eco-friendly. There is no hazard in using the electrolytes also.
So basically we are doing a hydrovoltaic power generation. Here we are using soil as a major part of power generation here. Here we are connected this device with two electrodes, copper and aluminium. And here this is a single prototype of this particular device. And here we just give a sponge over here so that we pour aqueous solution. Here we use is water and we just pour it, and due to capillary action there will be upward motion of these water against the gravity. So this particular device can give around 0.6 to 0.8 volt, and to glow this LED we need around 2 volt just for IoT applications, for small applications like that. So for that we have collected this in a series way, and currently it yields around 1.4 volt currently, so it's getting charged. To glow this we need 2 volt, and for this in a mega application we have connected this in 100 devices like this, and the output is we have given is around 90 volt. And this is from Hydrotech Power Generation Energy Tech Lab, and I'm from Physics Department, Gomati Shri.
This is basically power generation from green materials. So we have used algae here. So as you all know, in green plants, photosynthetic activity takes place. So what happens in photosynthesis? It's like light energy is converted into chemical energy, which is later on converted into electrical energy with our setup. So here, as you can see, algae, we collected it from the ponds here at Amrita, and this was like a sample which we didn't use for like 2 years, and yesterday we started using it, and it kind of showed the same result what we previously got. It's showing about some 1.2 to 1.6 volts. So that shows like the sustainability of this particular device. And here we have done this in a plain glass, and here we have used in an FTO glass. FTO is like fluorine doped tin oxide. So with a similar setup, but here you have to dip it in water always. But in this case, in the case of this one, we are just adding a drop of water to it.